Again, good morning. Yeah, thank you all for attending this webinar, for Banner Preventative Maintenance or Predictive Maintenance. And my name is Jim Mullins. I'm with iAutomation, and my title is, I guess, Machine Control and IIoT Specialist. And I was asked to give an introduction, so I got a few slides here, and then I'll turn it over to Banner. So I wanted to give just a brief introduction of iAutomation and Banner. So iAutomation we are a high-tech distributor with many engineering and value-add services. We have over 90 degreed engineers. That's about a third of our workforce. We represent 50 manufacturers plus, and we have been. Yeah.
Jim, I apologize for interrupting you, but somebody just sent in the chat that they can't hear. Can everybody else hear? Jim. Okay, good. All right, I'm sorry, sir, whoever that is. It sounds like it's on your end.
Okay, great. Well, thanks, Kathy.
Yeah,
okay. Yeah, but anyways, iAutomation, we've been a partner, been in partnership with Banner for over 20 years. And the type of value added capabilities that we provide, a lot of controls engineering, IIoT architect design and integration. We also provide electrical and mechanical design with drawings and such. We manufacture a lot of control panels. I think we manufacture thousands of control panels a year, extrusion assemblies, cables, and other like custom assemblies. And we do design IoT into many of our systems, and we're going to get more into the benefits of all that. But of course, increased productivity, extended equipment life, reduced downtime, and other advantages. And to say a little bit about Banner, Banner has been around since 1966. They're headquartered in Plymouth, Minnesota, with over 30 offices around the world. 5,500 employees and over 10,000 innovative products. And specifically, Banner specializes in sensor technologies, vision systems, LED indicators, wireless solutions, machine safety, and other products. But I think a key point is that Banner is a pioneer in the industry for integrating IIoT capabilities into machinery. And Banner offers a very comprehensive IoT, complete solution from sensors to gateways all the way to cloud services. So I think the big takeaway here is with the partnership of Banner and iAutomation, we provide expert engineering support, and work closely with you to make sure your IoT and automation systems are a success. Okay, let's see.
Thank you, Jim.
Okay, so the next slide is just to kind of give you an idea of what the the applications and software team members are. Just to kind of give you an idea of how comprehensive, and we cover from Florida to Maine, and we also are in Wisconsin, but we reach even beyond those areas for certain situations. We have we can provide machine controls design. Often we're on site for startup and commissioning, electrical panel design and fabrication, including a full set of drawings, IIoT architecture with commissioning and design, and also dedicated high level, we have high level systems engineering support and project management, especially for bigger projects. Okay. And why do we perform maintenance on equipment? So as we know, all machines do wear and eventually will break down over time. And performing a maintenance keeps the machines running efficiently, kind of just like you would expect in your car for getting oil changed, changing spark plugs and such. The same is true for machinery. So there's three types of maintenance that we typically perform. So the first one is reactive. we don't touch it till it breaks, and and that would be the time you would work on the machine is after it's already broken or has any issues. Preventative maintenance is more of a time-based where you would go out and lube, do inspections on certain sections and such. So just to make sure you're doing all you can to try to prevent a breakdown. And then predictive maintenance is a lot smarter, and it allows you to do maintenance on different parts of the equipment just in time, just when you actually really need to do it. So a little bbit more about reactive maintenance. You typically run the machine until actually something fails, and then when it occurs, then you provide the maintenance and change out a component or do whatever it needs. But you try to do that as quickly as you can to limit downtime. But that's not a scheduled event. So the benefits of this, it's low initial cost. There's less planning required, and then you get the maximum utility out of components because you're waiting until they actually break or fail. So the drawbacks are unpredictable downtime. Shortened equipment lifespan, and then the loss of productivity can be costly, and then it can introduce safety risks. So the preventative maintenance is typically planned, and it's again better to be safe than sorry. So maintenance is performed on a fixed schedule. And its aim is to avoid unplanned downtime. So the benefits are effective at preventing some of the unplanned downtime, and it improves the long-term productivity of the equipment. But the drawbacks, can sometimes you're doing too much maintenance. It could be expensive. Again, over maintenance, challenging to set up or optimize. Sometimes the maintenance can be, either too early or too late, and you still might have a failure. Okay. But with predictive maintenance, it's more of a just in time. The device performance regularly monitored to detect anomalies, and then you can, detect an issue before you have a failure. And the key here is to maximize uptime and avoid unnecessary maintenance. So the benefits, effective at preventing downtime. It improves the long time productivity of the equipment. You avoid over maintenance, when it's not needed. And then this is also very helpful for especially reaching hard to reach equipment. The drawbacks is it does require, it requires constant monitoring and trying to determine what measurements will predict maintenance needs, has to be discussed and, pinpointed. So each approach does have its place. The reactive maintenance is, it works good if it's a low risk item, and it's non-essential equipment, and it really doesn't have a big impact if the equipment goes down, and you can afford that downtime. But with preventative maintenance, recommended for general maintenance of all essential assets and lubrication of moving parts and replacement of wear parts. So, even though if you're doing predictive maintenance, there's still a blend of preventative maintenance you still want to do. But the predictive maintenance is meant to be more of a supplement to the preventative maintenance. You monitor the high value items, motors, gear pumps. I know we've done it on, $15,000 spindle motors that were just mission critical and very expensive, as an example. And of course, remote or hard to reach equipment. So what does it take to set up condition monitorings? And the first step is in condition monitoring, an example might be like in a control cabinet monitoring, like temperature and humidity or vibration and such. So the first step is data generation. You got to select the right sensors that create the data, and then you want to capture the data from the sensors. It could be in your PLC or machine controller, And then the data interpretation or analytics, where you're actually creating useful information from the data, and then actually creating an action, notification to maybe the maintenance manager or to the OEM or such who would actually take action. And why do we recommend Banner? So as I said earlier, Banner has a very comprehensive and complete sensor collection. And even in cases where they might be missing a few super specialized sensors, you can easily connect, like third-party sensors into the Banner system. They also offer a local and cloud-based data collection through their CDS. Plug-and-play configuration makes setup simple and easy. So I think we'll be going over this more in the next slides, but it is really easy to get set up. And then there's many ways to indicate system status. You can do it through lights. You can do it through like notifications with emails or texting and even other methods. So that is just a brief introduction, and I'd like to hand it over to you, Sean.
Hi, everyone. Great to be here with you all. Really appreciate everyone joining. My name is Sean Foley. I'm a global product manager at Banner Engineering, and I'm focused on kind of a lot of the things that Jim was talking about with regards to products that enable predictive maintenance and data collection, and primarily focus on a portfolio of products called SnapSignal. So SnapSignal and the presentation that I'm going to be covering today is going to be focusing on this bundle of products that really are an enabler of a lot of the predictive maintenance efforts that Jim was talking about, moving from preventative to more even going into the different maintenance strategies as we go up that chain, giving you the data that you need to kind of make those data-driven decisions, such as monitoring a motor, for example, to monitoring current. So today we're going to be talking about SnapSignal, our condition monitoring products. We're going to have some application examples where this technology has been implemented. And we're going to also have time, hopefully, to demo some of these products that we have available to make implementing this really, really quite effective and easy. So what is SnapSignal? I like to kind of start with that. SnapSignal, in a nutshell, is a portfolio of data collection technology that serves as an overlay network. So what do I mean as an overlay network? Typically, we're putting this over the top of an existing control system for collecting data. So when I say overlay, it means we're typically not disturbing an existing PLC or an existing control system. We're overlaying sensors and data collection on top of these machines, these legacy pieces of equipment that could be 20 plus years old. The average age of manufacturing assets in the United States is 20 years old. And giving people and organizations access to the data, whether it's vibration data on a motor, temperature data, current monitoring data, all sorts of different data types, we're able to bring it into this architecture. So this is called our SnapSignal data elevator. I know there's a lot going on here right now, but on the capture layer here, we have all these different types of sensors, whether it's a discrete sensor that might be counting objects moving by, IO link sensor, one of the many thousands of different IO link sensors that are available. Maybe an analog sensor monitoring things like tank level or pressure, perhaps, flow. We've also got some of our condition monitoring sensors, things from temperature and humidity, maybe monitoring temperature and humidity in a control cabinet or another environment where condensation can build up. Vibration, huge. This is one of our VT2 sensors, or we have a new version of 3-axis vibration sensor that can be mounted on a motor. We've also got something as simple as our current transformers, this product right here, to monitor the current draw on assets. But the key here is we have all these different sensor types. And what the real interesting thing and powerful thing of SnapSignal is we're able to capture data from whether it's a condition monitoring sensor that we offer or any other sensor, convert it over to a unified serial Modbus RTU protocol with these little converters that are about the size of a AA battery, and bring it into this, what's called our DXM R90 industrial controller. This acts as the consolidator for that data. So this product has 4 individual Modbus client ports. So what's the power of Modbus? Well, power of Modbus is it allows you to run extremely long cable lengths from your sensors to the controller. It also has the ability to pull in data from lots of server IDs. So each individual Modbus client port can connect to, in theory, with Modbus RTU, 247 Modbus clients. Usually we don't recommend that many per port, but you see the value in having a scalable solution where you maybe want to start adding more sensors. You might start small at this and adding, vibration or current monitoring. But once you have all this data that's gathered into this industrial controller, we're able to send the data where it needs to go. You're not locked into a system. This port here supports industrial Ethernet, so Ethernet IP, Modbus TCP, Profinet. It also supports MQTT to send data to MQTT brokers or sending data to cloud platforms such as Banner Cloud Data Services, for example. So many examples with SnapSignal, we have flexibility with not only the sensors that you use with our converters. It makes us brand agnostic. We've got a very formidable portfolio of condition monitoring sensors, but it gives you the flexibility to add different types of sensors, whether it's from Banner or not. And once it gets into the industrial controller, you could send the data where it needs to go. An example would be like a SCADA system, such as ignition via Modbus TCP or MQTT. This is a great portfolio for SCADA systems. So bringing data into a SCADA platform, for example. Oftentimes we're sending this data to an HMI screen. Sometimes we're even sending it to things like AWS IoT Core, or again, like ignition via some of those cloud-based protocols such as MQTT or HTTPS push methods. So we're going to be talking about this, each individual layer. But before I start, I want to talk about kind of what SnapSignal solves. Walking into so many different end users, I can almost guarantee you there's some sort of initiative in place where they're trying to reduce downtime, like Jim mentioned, with preventative, different maintenance strategies, collecting data, moving from preventative maintenance to having a continuous data collection system. They're trying to improve their delivery times. They're trying to lower their costs, improve quality, increase the throughput of their machines, and trying to maybe optimize their labor force. Again, going with a kind of a maintenance strategy where someone's going around with a clipboard, monitoring gauges on a machine, for example. That's an example where labor could be optimized by having a continuous data collection system in place. So SnapSignal can be used to improve any of these, can be used to collect data for any of these types of initiatives. So sometimes when you're starting with an IIoT deployment or data collection deployment or preventative maintenance deployment or maintenance strategy, it's important to start looking at these high-level goals. What are your overall goals as an organization? Perhaps it's to reduce downtimes for your facility by, say, 30% in the year 2030, for example. You need data to make those improvements. You can't do it blindly. So let's move on. I'm going to talk a little bit about, I'm going to move through this fairly quickly, but again, moving from reactive to preventative to predictive with regards to maintenance strategies. And when we look at our kind of a playbook, we call this the think big, start small, and scale fast approach with deploying this type of technology. So think big, what do I mean by that? Think big, I mean thinking of your corporate goals as an organization. What are you trying to do? What are your high-level goals? Perhaps it's to do with labor optimization. Perhaps it's to do with downtime events. Start small, find a high-value entry point. So for example, and a great example of a high-value entry point would be something like a motor. A failed motor can be a maintenance manager's worst nightmare. A motor could fail and you could have instantly revenues are in jeopardy. The cost of downtime per hour I've seen in the hundreds of thousands of dollars when they don't have a monitoring solution like one of our vibration sensors in place. So starting with a high value entry point, gathering the data from those assets and gaining confidence in the data and how you could gather it, maybe even catching a failure or two. And then as you start to build momentum, you could start scaling up and adding more sensors, more devices to your SnapSignal ecosystem. If you have any questions, just feel free. I get really excited about this stuff. So if I need to reel it in, just let me know. What's another example of starting small? Perhaps one of my favorites is current monitoring of a motor. So being able to capture data on a motor, for example, seeing the current draw with one of our CTs, being able to class that around, bring it into one of our DXM controllers, getting the baseline current draw of an asset, such as a motor. So you're able to see how it operates at the baseline, if it's under a high workload, if it's under a low workload. You even start to see things like such as if the belt is starting to slip on the motor, the current draw starts to fluctuate. You start to see if it's maybe operating at all, if it's under no utilization. By using this data, bringing it into a controller and monitoring in a cloud platform or SCADA system, you can even set up alerts where you get a text message alert or an email alert if that current or voltage goes above or below a certain threshold, for example. This is a current monitoring device, very commonly used in combination with vibration for monitoring some of these assets. So I'm going to move through this next part quickly because Jim did such a great job of explaining moving from reactive maintenance, waiting until it fails, to preventative. You know, a lot of times I see with preventative, it's the clipboard mentality where you're monitoring, say, a motor with a clipboard on a weekly basis. But like one thing I've noticed is sometimes that's not the most effective strategy. One thing I've seen is clipboards have erasers, and sometimes it's easy to maybe miss a measurement. Another thing that's important is machines don't fail on a schedule. You could have a motor that's operating perfectly Wednesday, and Thursday it has a catastrophic failure. Having a system that's continuously monitoring that data and having an alert system in place for that check engine light approach is highly effective in this predictive maintenance strategy. So let's talk about some of our condition monitoring sensors. I'm going to move through this fairly quick. I have a lot to cover, but one of the key pieces of our portfolio is vibration monitoring. So this is our QM30VT3. We have two versions. We've got the 3-axis and the 2-axis. It's actually brand new. The 3-axis vibration sensor. So these are used to monitor motors, gearboxes, bearings, pumps, fans, compressors, and it helps in these types of areas. Essentially, in a lot of cases, serving as the early fault detection, preventing those catastrophic failures, preventing those unscheduled downtimes. We're trying to find the failure before it starts to move through this chart that you see here. The failure begins. We want to catch it as early as possible in this failure curve with these vibration sensors. These vibration sensors also monitor temperature of where it's mounted. And we've got different mounting accessories, magnetic mounting accessories for mounting these on a motor. And with the new 3-axis version, it gives us a lot of flexibility with to mount this. So it's a 3-axis sensor. So you could have a lot of flexibility of where you're mounting this sensor on your motor. Another thing to point out is we also have stainless steel models available, but you could see here how you could mount it very flexibly on different areas of the motor. It gives you a lot of flexibility, an improvement over the 2-axis version. But we're able to gather data on the X, Y, and Z axis. And we also have some advanced features. We could capture the data, time-based waveforms on the X, Y, and Z axis in real time, and provide FFT data, so full spectrum analysis for those different areas. Another thing that's extremely powerful about this device is onboard what's called VibIQ. So this is a new feature on our 3-axis vibration sensor, but essentially what VibIQ allows you to do is you could run VibIQ on the sensor itself as opposed to in one of our DXM controllers you had to do previously. And what is VibIQ? What it does is it learns the baseline behavior of the motor and automatically sets up alarm thresholds for you. It takes all the guesswork out of setting up those alarm thresholds. So you could have VibIQ running on your motor. It learns the baseline behavior over a period of time, and then it automatically sets up those alerts for you. This is extremely useful if you're new to vibration and you want to have that check engine light approach and get started really quickly. So again, it's designed to make vibration monitoring simple. This sensor, I could talk at length about some of the advanced features within it, but it's designed to make it simple for somebody who's new to vibration or someone who is a vibration expert. We'll see a tremendous value in some of the advanced features within this sensor. We've got a ton of collateral on this. I want to move forward because I get very excited about this sensor and what it can do. But vibration, what do these values tell you? One thing it's kind of good rule of thumb. You could start to see by monitoring the RMS velocity, which is coming from the sensor, and the high frequency RMS acceleration. It could be indicative of things like soft foot, misalignment, imbalances within your motor. And then the high frequency RMS acceleration that you could gather with this vibration sensor, that's going to be indicative of some things like a bearing failure, perhaps. Displacement on a motor, it's often something you could see. Velocity, it's something you could touch, so you could feel that actually shaking. As well as acceleration, something you could usually hear when you're looking at a motor. What are some other sensors that we have? Vibration is one of my favorites. I love talking about vibration, and there's so much content I could share with you on that. But there's a lot of stuff on the website that we could cover at the end here. And if you have any questions, just feel free to reach out anytime. Another area is current monitoring. Kind of like what I mentioned before with monitoring not only the vibration and temperature of a motor, but maybe the current draw. So we have different current transformers depending on the size. So for example, this is a 20 amp current transformer. This is a 600 amp. You notice the size difference there depending on the amperage of your of the conductor you're monitoring, the asset you're monitoring. Another thing that's important to note is the diameter of what you're classing this onto. Sometimes it's a thicker cable. It's a thicker conductor that you're monitoring. We even have devices such as our Rogowski coils. Look at this guy. This is for monitoring things up to 3,000 amps. So you can kind of see the range of products. We've got a full portfolio of current monitoring devices. And then we're bringing this into converting this over to Modbus and bringing it into our DXM controller. So why is it important to monitor current? It's good to get an understanding of the power consumption of your assets, machine utilization time. Maybe you want to start looking at machine stop-start cycles, for example. Maybe you want to look at insight into your motor loads. If it's working at a high workload or a low workload. Maybe you want to see just long-term trending by monitoring current of your various assets. Another thing too is we also have voltage monitoring, AC voltage. So things like monitoring power consumption of an asset for energy savings initiatives. Maybe you want to reduce the amount of energy your assets are looking. You need data to start seeing what's the energy that my power consumption that my devices are starting to pull. How can we optimize that? You need data to kind of make those improvements. Again, it's a great way it's a great 1-2 punch device, particularly in monitoring, getting that check engine light approach for monitoring motors is a great example. Monitoring current on motors as well as vibration and temperature. We've also got temperature monitoring sensors, things like thermistors. RTDs are something we've been able to convert over as well. So we have converters like this that makes us brand agnostic to basically pull in data from any RTD that's on the market. So this is, again, a nice approach with our converters. We're brand agnostic. But we also got our own contact temperature sensors. One of my favorites is a non-contact infrared sensor. Being able to point this infrared sensor at an asset, non-contact, uses a thermopile, and it continuously monitors the surface temperature of that asset, but it's non-contact. You could be a distance away from the asset. So maybe monitoring the temperature of a rotating bearing, or maybe another asset that you don't want to have contact on the asset to monitor. You want it to be non-contact using infrared. This sensor is the same size as this little S15C. It's about the size of a AA battery. Another thing is temperature and humidity monitoring. Very useful in monitoring things like temperature and humidity in a control cabinet. Something, electricity and humidity don't mix well. And sometimes monitoring the humidity in some of these vastly critical areas such as a control cabinet. You could have things like humidity building up, condensation building up within the control cabinet. These are extremely useful if you want to have an effective kind of check engine light, or even having an automated system in place where you could use the sensor data. If it goes above a certain temperature or humidity, it turns on an air conditioning system. Some simple logic like that to improve the ventilation, or turning on an AC unit or a mister, for example. An example would be a guitar manufacturer who's using these because the wood for the guitar had to be within a very precise window of humidity. Otherwise, it was causing quality issues on the actual guitar itself. Another example would be bottling lines. Things like condensation were building up on the bottles, and that was causing labeling issues. The labels wouldn't adhere to it, so needed to have a way to collect the temperature and humidity data. Pressure monitoring. So we have a range of pressure sensors as well as pre-scaled converters that allow you to bring in the pressure data, things on compressors, pumps that you want to start monitoring, as well as differential pressure. So differential pressure, this is a great device. You kind of see the two connections here, extremely useful for monitoring things like filters, seeing if a filter is clogged. The one thing I'd like to mention is more sensors equal better insight. You may start small, maybe something as simple as a vibration sensor on a motor running VibIQ, but maybe you want to start to see, well, I'm seeing the vibration data. What's the current looking like? What's the temperature looking like? You could start to build out a scalable system with a snap signal approach, and being able to pick and choose whatever sensor type you need to use, whether there's a banner sensor or another manufacturer sensor with one of these converters. On the converter subject, these are kind of the secret sauce that makes everything work so well. It's the thing that makes us brand agnostic. We've got converters that could take in 4 to 20, 0 to 10 volt signals, RTD signals, thermistor signals, discrete signals. That makes us brand agnostic. So you could use just about any sensor, whether it's from a flow meter, an oil particle monitor, proximity sensors, and bring it into this ecosystem. So it's just so highly flexible. An example would be being brand agnostic. This is a great example where Dwyer Magneheel, like a differential pressure sensor, was being used with one of our S15C converters. This sensor, previously, the customer was copying this into a clipboard. And moving towards, the different strategies as we move up the strategies for maintenance with regards to what Jim was mentioning, this is something where they're collecting data, copying it into a clipboard. What they didn't know is that there's also a 4 to 20 milliamp output on this sensor, so we quickly were able to retrofit a lot of these differential pressure sensors and bring it into a continuous data collection system with this converter. Discrete monitoring. So this is one of my favorites as well, and I get pretty excited about this for the two facts. The power of a single discrete data point. So this particular converter, I'm going to grab it over here. It's the S15C B22. So this converter allows you to basically tap into existing discrete sensors that are already on a line, plug it into a parallel wired splitter. So the signal that's already going back to a control system is able to be pulled into this S15C converter. So we're able to split that signal, so it's still going back to the control system, but we're still able to capture that discrete data and bring it into our DXM and send that data to the cloud, to a SCADA system. And where's the value in this? Well, locally, within this converter, there's registers that monitor the overall part count, the parts per minute. You start to see the OEE metrics of a single discrete point. So this video kind of highlights, you can plug in a parallel wired splitter into an existing discrete sensor, one branch going back to the PLC, one branch going into our DXM. And from the DXM, we're able to send that data that's stored locally in registers, Modbus registers, on this converter, and then push that data to the cloud via this decode industrial Ethernet connection. and set up simple dashboards. So things like, this, you'll see it here in a little bit, but things like being able to see what's the status of the machine, what's the parts per minute, what's the overall part count for the day. They're stored locally in registers on this converter. So you might not be able to see this, but you can see stored in local registers that are continuously being captured. You're able to see the overall part count, the on time of the sensor, the off time of the sensor, the events per minute. All that data kind of allows users to make those kind of data-driven decisions from an existing discrete sensor that was previously locked into the PLC. We're now doing two jobs with one sensor and getting insight into a legacy machine, such as perhaps, you know, one operator's operating the machine at, you know, at a certain time of day, and then another operator's working, and then you're noticing the part count for that machine is 20% higher from one operator to the next. Or maybe you want to know which machine that you have across your facility is operating most efficiently. So during peak season, for example, or high sales, or whatever it may be, large drop in order for a product, they want to utilize which machine is best for them. I'm going to move through these quickly, but if you have multiple discrete sensors or analog sensors, we've got multi-port hubs versions of these same converters. So let's say you have multiple discretes or analog signals you want to monitor. Sometimes it's more cost effective to use something like this, a multi-port approach. So if you've got an R95, this is the 95 millimeter housing, so it's called the R95 series for monitoring discrete data, just like that discrete sensor I was talking about before. Same for analog. So if you have multiple analog signals that you want to monitor, 0 to 10 or 4 to 20 from any manufacturer, let's say you have multiple, it's going to be more cost effective to probably move to a multi-port version as opposed to using 8 of the S15C converters. This is where it gets interesting. We also have hybrid hubs. So if you have a mixture of different signals that you want to collect data on. So discrete on this channel, on this side, 8 discrete inputs, as well as 4 analog inputs on this port. So a hybrid approach. Basically consolidating 2 or even 3 hubs into one with this approach. Okay, so let's talk about the DXM. So again, I like to think of this as the consolidator. You're gathering this data, you're converting it over to that unified serial protocol if necessary, or using an existing RS-45 or Modbus RTU protocol device. From here, you're able to send that data where it needs to go via this decode industrial Ethernet port right here. So things like such as AWS IoT Core, SCADA system, an HMI, even a PLC, you have a lot of flexibility where you could send the data. Modbus serves as a highly scalable protocol. You could run long cable distances, and we'll talk about this in a little bit. You can even incorporate wireless attributes to it as well. So the DXM R90 industrial controller, it has 4 individual Modbus client ports here. It has Ethernet IP, Modbus TCP, Profinet, as well as MQTT protocols. This version also has Ethernet and power pass-through, so you could have these on a network as well. Each one of these would have its own IP address, so you could actually daisy chain these essentially on a machine if you needed. An example would be something like this. But again, with Snap Signal, it's kind of like the Lego building blocks you need for collecting data. You could kind of pick and choose what you want to monitor. Perhaps you want to monitor vibration on these 2 motors, maybe tank level with a 4 to 20 analog signal being converted, or even temperature monitoring with a non-contact infrared sensor. Another thing that's important to note is incorporating lighting products. So this is a demo that highlights that we also have lighting products that could be incorporated, adding a visual factory element. So maybe you have an analog sensor such as a photo eye or a pressure sensor. We're converting that over to that RS-45 protocol here and bring it into our DXM. In our DXM, we've got advanced programming that allows us to do action rules, MicroPython, script basic programming, to do simple logic to write the scaled analog values to lighting products very well. So maybe for tank level, you want to monitor the tank level, send that data to your cloud or SCADA system, but perhaps it's helpful for locally on the machine to incorporate a visual factory element to some of your personnel. In other devices, we have a temperature and humidity sensor, and that's being displayed the temperature. We're just reading in the Modbus registers into the DXM, doing a little bit of scaling, and then writing it to this light here that still operates on that Modbus RTU protocol. So a great example of incorporating some visual factory elements into some of these overlay systems. Here's an example with roll diameter monitoring with analog sensors. So I've talked a lot about wired infrastructures, but what if I don't want to run a cable 1,000 feet across my factory? This is where these R70s become extremely useful. We have a Modbus client R70 here and a Modbus server R70 here, and that could collect data from these data islands, effectively breaking that M12 cable that these use and sending that data wirelessly across your factory over 1,000 feet if necessary. So if you have things, assets, maybe you have locally, you have wired devices that you want to connect to your DXM, but 1,000 feet across your factory, you want to monitor essentially like a data island, a cluster of devices. You could incorporate these R70s. Extremely easy to implement. You twist off the cover on these, set the dip switch settings to be a client, repeater, or a server radio, and then you bind the radios and you're done. They're extremely cost effective, extremely plug and play for wire replacement in some of these applications. A great device. Here's an example with a tank level with an analog hub. So they want to monitor multiple tanks. Again, the analogy could be used for pressure, flow. They wanted to send that wirelessly from this hub, the analog data being collected, back to the DXM that could be hundreds of feet away, for example. So a great wire replacement device. I'm going to talk a little bit about the AMG. Before I do that, though, I also want to mention we have the ability to pull in any IO link sensor into this Modbus ecosystem as well. We've got connect any IO link device and convert it over to that RS-45 protocol with a 2-port IO link master. We've also got the 4-port IO link master, and you could daisy chain these kind of on a network for collecting data from any IO link sensor. So again, being able to be brand agnostic, pulling in data from these different sensors from different manufacturers into this ecosystem. Even doing things like wireless IO link if you combine that with the R70 serial data radios. I'm going to talk about something when you're setting up a system, your first system. It's called the AMG. This is essentially what SnapSignal is made into a deployable system that you could deploy in minutes, as opposed to having to dive into the software tools. The DXM, great device if you want to use, have configurability. If you want to get started and pilot a system extremely quickly, the AMG is just a fantastic device. I'm going to show some slides here on the AMG. So the AMG provides a way to collect the data from these Modbus devices. You could connect up to 20 devices, and it collects the data continuously. I'll show you in a little bit how this is configured. So we're able to push this data out via this Ethernet port here at the bottom, or sending the data to a cloud platform such as Banner CDS. This also has the ability to push data cellularly to the cloud. So cell networks, you could also push data to the Banner cloud data services. But you could monitor up to 20 different devices that could plug in right on this port that you see right here. So all these different Modbus devices that we have connected. Sorry, Brad, I'm kind of moving it around. My apologies. But you see kind of this device that we have connected to one of just a passive block. We have a vibration sensor. We have an infrared temperature sensor. We've also got an analog converter that we have here. So the key attributes I think are powerful about this. It's the quickest path to machine monitoring via the SnapSignal portfolio. There's no config software necessary. If you're using our other controller, you need to use the DXM configuration software. This is commissioned on the HMI screen on the device. So you don't, it's extremely plug and play. You could wire, manage and monitor up to 20 snap signal converters or wired sensors with this machine. There's also a way to set up alerts locally on this machine. So you could go in, read in the devices that you have connected, the 20 devices, each one will have a server ID. This device will pull in all that Modbus registered data. And we could also set up alerts locally on this HMI and have even a light that indicates when an alert is passed. But it makes commissioning a network extremely easy. So the bundle itself, and then of course we have different ways for sending the data where it needs to go. You could send the data out via Ethernet on this industrial Ethernet port here, to the cloud via cellular connection via Verizon, AT&T, other worldwide cell connection options. And it's highly repeatable and scalable in many different systems. So I've seen tons of cases where people just want to get started, develop a pilot system. This is an excellent way to do that very effectively. If I have time at the end, I'm going to demo it a little bit on how to set up alerts here and read in data on the AMG. So the AMG, you select a gateway based on if you want just Ethernet only, Ethernet with a year of our cloud data services package, Verizon, AT&T, worldwide cell modules. Select the sensors that you want to monitor, maybe vibration, current, temperature and humidity, non-contact temperature, all the devices kind of we're talking about. Select your brackets, select your connectivity. We've got a bundle builder online called the AMG Bundle Builder. If you Google that, you'll be able to find a way to, essentially a way to make this process automated on our website. And so this is essentially how the bundle builder works. Identify the equipment that you want to monitor. So this is where it's important to know cable distances of when you're starting to monitor these things. Maybe you want to incorporate our 70 radios. And then you start planning out a system. So you provide power to the asset monitoring gateway. You pick your sensors. What do you want to start monitoring? Maybe level, vibration, current, temperature and humidity, pressure. Select the brackets for mounting these devices. Connect the sensors to your gateway. And there's different connectivity options with the RS-485 protocol. Passive wire M12Ts are commonly used. Or even multi-port junction blocks like this 4-port splitter here. And then this is where it becomes important to start looking at your cable lengths. And then you have a banner bundle, and it kind of makes it nice and easy for building out a bill of materials for starting a pilot. Another thing that's good to note is you could also incorporate these R70s into this system as well. So the R70s I was talking to you about, if you want to have a cluster or data island set up where you have assets being monitored locally, you could have both wired and wireless infrastructures going to the AMG and reading that data in. So an example, I'm trying to think of a good example of where we've used snap signal. One of them was on an injection molding customer, and they had a fleet of hundreds of injection molding machines. They had some issues that they wanted to monitor. So they wanted to monitor the vibration and temperature on their motors. One thing that would happen is if a motor was to fail, they'd not only have downtime, they'd also have expedite charges from the OEM to replace the motor. So they'd have to expedite the order and pay a fee of a large sum of money to expedite the motor shipment. They also wanted to monitor the tonnage cylinder that actually presses the injection molding machine together. Oil is leaking past the piston in some cases. They wanted to monitor the temperature and humidity in the hopper because they're experiencing an issue called splay on the injection molded parts where there's a surface defect on the injection molded part. In the summer months with the high humidity, the pellets that were going in the hopper were not being dried enough. And that was causing issues with scrap. They're having to throw away all these injection molded parts by the hundreds. And that lot costs money, and it also wastes time. They also wanted to monitor oil temps, pumps, the cooling system. And so this is kind of the areas we decided, to monitor in this case. And the initial pilot was something as simple like this. It was literally a napkin sketch, monitoring vibration on the motors, temperature and humidity in the hopper, thermistors on the hydraulic cylinder, because oil would leak past that cylinder, and if it would cause a large spike in temperature on one of those thermistors if the oil was to leak past, as well as current monitoring on the motors, brought into the DXM. But you kind of see how it's all very scalable with the M12 connectivity, with that RS-45 protocol, to use passive wired splitters. Connectivity plays an important role in this. And literally planned out the system before. Again, it's an overlay system, so it doesn't cause the machine to experience lots of downtime. The machine's still, maybe a couple minutes to actually install this, 30 minutes to install an overlay network. We're not bringing the system down. We're not bringing the PLC down. We're not diving into the control cabinet. We're overlaying this. So to actually be able to commission it before even installing it on the machine. So things like current monitoring here, thermistors, vibration, all being pulled into this DXM. And this customer ended up setting up a very simple dashboard in the cloud, in our Banner Cloud data services. Another area is compressors. I could talk a little bit about compressors, but I'll share this information after, because I also want to mention that this is also on our website. If you have any questions on Snap Signal, we have our snapsignal.bannerengineering.com. A great resource as a starting point to learn more about Snap Signal, have an overview video. We've got information on all these individual components, converters, our condition monitoring sensors, serial data radios, the AMG, as well as some of our other cord sets and accessories, things you use to build a system out. And then at the very top here, at the very bottom, we've got application examples, use cases, but there's also a really nice brochure that you could find here as well. So you could download that here. And this brochure is a great starting point to learn more about Snap Signal. We've got hard copies available as well if you need them. A great resource for kind of going through, looking at where you want to monitor current, vibration, temperature and humidity perhaps. What do you want to convert over? How do you connect them? What cord sets do you need? As well as some good kind of application examples, information on all our individual converter products. They can be found within here. So a great resource. If you have any questions, feel free to reach out anytime. I know I covered a lot of information. I apologize I went a little bit over time here, everyone. I get really excited about the products and the portfolio. So is there any questions that have come through? Thanks everyone so much for their time. I really appreciate it.
Hey, Sean. Yeah, just one question primarily, which was just about, and maybe you can offer a little bit of insight, but
Yeah.
Someone was asking about the selection of Modbus as kind of the backbone versus something like a CAN bus, right? So I guess sort of from the product development standpoint, why you guys maybe settled on Modbus as a backbone.
Yeah. It's Modbus, it's been around for so long. It's been around since I think the 70s. So people know Modbus, but I think there's almost an aversion sometimes of Modbus. I actually think with data collection is a tremendous advantage. The ability to run long cable lengths is one. The fact that it's a robust signal is another thing. Usually you don't need to worry too much about cord sets. Standard M12 connectivity is good, but also the ability to pull in lots of data into the DXM. So, whoops, I'll pull it over here. The ability to pull in on these Modbus clients and pull data from Modbus servers like our converters or our sensors that are serving up that Modbus register data, being able to connect 30 devices or more on these ports allows you to connect a lot of data on one single device, one IP address, one controller as the consolidator. Other data collection methods, there's many out there, but they may have only one device per port, and that adds costs. So I think for scalability, it's a great protocol. For the long cable distances, it works really well. Also for the wireless approach, being able to incorporate wireless serial radios as part of the wire replacement. Speed sometimes comes up, so the speed concern, but I think with data collection, again, we're not typically going to a PLC. Modbus, you'd be surprised, can be surprisingly fast with a wired ecosystem. So even if you're pulling data and sampling let's say you're pulling data from vibration on a motor, temperature and humidity or pressure, if you're monitoring that, say, every 10 seconds, that's still probably going to be a lot more data, a lot quicker than the clipboard approach that kind of we're talking about with the preventative maintenance strategies. So I think Modbus has some, I think, very good advantages with regards to this, and also it's robust.
Great, thanks, Sean.
Somebody mentioned that the DXM doesn't look the same while talking about the gray versus black.
Oh, the DXM doesn't look the same. Yeah, so we actually upgraded. This is actually my old unit. I've had this for too long, but we upgraded the labels on our DXM controller. You kind of see this is gray. Good catch. But we've updated this to a black label, so it kind of looks more. Let me find a good example here. It'll look like this product on the DXM. Kind of see we did a little bit of a facelift. The nice thing is with this version that is also a QR code on the back, so you can get product information. Uses inkjet, so a nice update to the facelift to the product portfolio there. Is there any other questions? I'll be happy to. If you have any questions after too, feel free to reach out to us. Thank you so much.
Gary.
Great work, Sean.
I really appreciate the time, everyone. I know I covered a lot of information, but if you ever need any additional information, feel free to reach out to us anytime. We're here for you, and thank you so much again for joining on your Friday. Have a great weekend, and I'll talk to you all soon.
Thanks, Gary. Thank you guys all for attending. We really appreciate it. iAutomation, and if you want us to come in and take a look at your application, we will do so. Thanks, everybody.
Thanks, everyone.
Yep. Yeah, thank you.